Hello, my dear students and the rest of the learners. Welcome to this presentation in which we are going to be looking at the topic elementary programming principles with examples using Pascal. I have covered this topic under 4 presentations running from part 1 of 4 to part 4 of 4. This is part 1 of the 4-part series under the title Introduction to Programming. My name is MemJM, or you can simply call me Emily Swap. In this presentation, we shall look at the following. Number 1 is the definition of programming. Number 2 are the levels of programming languages. Then number 3, we shall look at an example of a program in Pascal. Then we shall look at number 4, the data types. Number 5, we shall look at the advantages and the disadvantages of low and high-level programming languages. And lastly, we shall look at the description of terms used in programming. Let's now commence by looking at the definition of programming. When we talk about a computer program, we are referring to a series of coded instructions for the computer to obey in order to solve a particular problem that have been developed with the use of a programming language. A programmer, on the other hand, is a specialist whose main work is to develop computer instructions using a particular programming language in order to solve a particular task or a problem. A problem is any task that requires a solution and can be simple or complex. Every programming language requires the programmer to code or write the set of instructions using a certain syntax. And therefore, a syntax in a programming language is a special sequence or order of writing characters in a certain programming language. Programming, on the other hand, is the process of developing computer instructions using a particular programming language in order to solve a particular task. A programming language is a special set of symbols that can be translated into machine-readable form by the computer when arranged in a particular sequence or order. A structured programming or structured programming is a methodology that stresses the systematic design, development, and management of a program development process. So, what are the 4 main activities involved in programming? The 4 main activities involved in programming are: number 1, the programmer or an individual designs and tests an algorithm as a solution to a problem. Secondly, he or she has to call algorithm into a computer program using appropriate language. Then the third activity is to test the computer program that one has coded in order to find out whether it solves the intended problem. Number 4, one has to document the computer program so that it can be maintained by others at a later date. What are then the functions of a computer program? The main function of a computer program is to process data into information. When I refer to the term data, I am referring to the raw facts and the figures that have no meaning to the user, while information is processed facts that are meaningful to the user. My dear students and the rest of the learners, if you want to gain deeper understanding about what data and information is, kindly visit the YouTube channel by the name Emily Swap ICT and look for the video by the title Introduction to ICT or Introduction to Computers. The data originates from outside the computer and must be loaded into computer memory before being processed. A program, therefore, performs the following tasks or activities. Number 1, it accepts data from outside the computer as input. Secondly, it carries out a set of processes on the data within the computer memory. Number 3, it helps store the data that has been attained for future use. And number 4, it presents the results of this processing as its output. At the levels of programming languages, an instruction set is a set of instructions that the computer can recognize and are directly converted by the hardware into some simple instruction. The variety of programming languages that can be used to write a program are broadly classified into 2 broad categories, which are, number 1, the low-level languages, and number 2, the high-level languages. When we are speaking about the low-level programming languages or programs, we are referring to programs that can be easily understood by the computer directly, or those that require little effort in order to translate into computer understandable form and are hardware oriented. They are a machine readable language in which each instruction corresponds to a machine instruction. The languages are hardware oriented, or the low-level languages are hardware oriented, and for this reason, they are not portable. That is, a program that is written for one computer cannot be installed and used on another computer. They are therefore said to be machine dependent. The two main types of low-level programming languages are, number one, the machine language, and number two, the assembly language. When we speak about high-level programs or high-level programming languages, we are referring to those programming languages that are very close to human language. That is, they are written or coded in English-like statements that can be understood easily and are user-friendly, but they must be translated into object code before execution, either by a compiler or an interpreter. I will discuss what a compiler or an interpreter is later in this presentation and in the subsequent presentations. They can be read and understood even by people who are not experts in programming. The high-level languages are languages that are machine independent. This means that a programmer concentrates on problem solving during a programming session rather than how a machine operates, because they are not specially designed for any one brand of a computer. The 5 types of high-level programming languages are, number 1, structured or procedural languages. These ones normally form what we call the 3rd generation. The 4th generation languages, or what we call 4GLs, we have 5th generation languages, or 5GLs. And then we have object-oriented programming, or OOPs languages. And lastly, we have web or internet scripting languages. A program is normally referred to as low level when it is closer to the language that the computer itself uses, while it's called high level when it's closer to the language that humans use. Let's now look at the 2 low-level languages. We commence by looking at what we call the machine language, or what we refer to as the 1st generation languages in the history of programming languages. Machine languages are programming languages in which data and instructions are coded in binary form and are understood directly by the hardware that they are designed for. Many lines of code, in this case, are needed to accomplish even a single task or a simple task. The arrangement of binary differs among computers because of different hardware designs and architectures. Each design of a computer has a specific machine language that is unique to itself. And therefore, this level of languages are hard to understand from the programmer's point of view, mostly because this code mostly consists of zeros and ones or a set of instructions coded or written in form of a series of zeros and ones. But this language is very easy to execute from the programmers, that is, from the computer's perspective. This is simply because it is entirely made of ones and zeros. So, to program in a machine language, the programmer must have a specific knowledge of the architecture and the operation of a particular design of the machine. The instruction format of a machine code has two main parts, which are a function or operation code and an address, or what we call or we refer to as operand. The function code tells the control unit of the central processing unit what to do with the item that is held in the address. An example of machine code instruction is as follows: 0, 0, 1, 0, 0, 0, 0, 1, 0, 1. 0, 0, 1, 0 means load instruction, and we refer to that as an operation code, while 0, 0, 0, 1, 0, 1 is the address of what we are calling the operand. So 0, 0, 1, 0, 0, 0, 0, 1, 0, 1 means load the contents of location number 5, which in binary form is 0, 0, 0, 1, 0, 1 into the accumulator. So, based on this example, we can say that the following are the main characteristics, or what we refer to as the advantages and disadvantages of the first generation languages. On the side of advantages, the machine language or first generation language is highly efficient and it allows direct control of each operation. Secondly, it is fastest to execute because it's already in the language that the computer understands. But it has some of the following disadvantages. Number one, it is difficulty to decipher. This is because it requires the aid of a reference manual in order to know the meaning of the code. Secondly, it is easy to make mistakes in the sequence of ones and zeros while coding. Number 3, it is time consuming. That is, it is tedious to the programmer to write. Number 4, it is machine dependent. And for that reason, it is not portable. My dear students and the rest of the learners, when we speak about portability of software, we are simply referring to the ability of a program or a software to be installed and used in a number or a variety of computers, regardless of the computer that was used by the programmer during the process of developing that program. Increases. Let's now focus on assembly language, or what we refer to as the second generation languages. These are programming languages in which data and instructions are coded as a set of symbolic operation codes that we call mnemonics, which are shortened 2 or 3 letter ones and are translated by assembler into object code. This language is close to machine vocabulary rather than the human being's vocabulary. The assembly language or second generation languages were developed in order to overcome the difficulties of understanding and using machine language. The programs written in this language require an assembler in order to convert it into machine language that the computer can be able to understand. They are easier to understand and are machine dependent, just as is the case for the first generation languages. This simply means that a program can only function, can only be installed, and can only work in the specific machine that it was developed for. Assembly languages are described as low-level languages because for every assembly language command, there will be one corresponding machine code instruction. And mnemonic codes or mnemonic codes represent operations, addresses that relate to main memory and the storage registers of the computer. The following is an example of a program code that is used to add and store two numbers. The first instruction reads LDA A, 20. The second instruction is add A, 10. The third instruction is store B, A. And the last instruction is NOP. So, what does this program mean? The first instruction, LDA A, 20, means load accumulator A with the value 20, then add the value 10 to accumulator A. After that, store the contents of accumulator A into storage register B and end the operation. So, based on what you have seen, my dear students and the rest of the learners, from the set of instructions that I have demonstrated to you, written in second generation language, you can be able to tell some of the main characteristics or advantages and disadvantages of writing or developing a program using second generation language. So what are some of these advantages? Number one, assembly language is easier to write than the machine language. Secondly, assembly language or second generation languages have closer control over the computer hardware and executes very efficiently. Number three is that second generation languages have fast and efficient use of the central processing unit. However, the second generation programming languages also have certain disadvantages, which include, number one, it's machine dependent and therefore not portable. Secondly, a program that is coded using second generation language must be translated by an assembler into machine language first before execution, and therefore this takes longer time to be executed as compared to first generation languages, which we have referred to as the machine language. Let's now focus on high-level languages. We begin with looking at structured or procedural languages, which we normally refer to as the third generation languages or 3GLs. When we talk about structured programming languages, we are referring to programming languages that makes it possible to break down a program into modules, therefore being flexible, easier to read, and modify. The structured languages enables large programs to be broken down into modules that perform a particular task using simple control structures in problem solving. This is called structured programming. So, when we are referring to structured programming approach, we are saying that this is a programming approach that emphasizes on the following. One, large programs can be broken down into smaller subprograms with each performing a single task. Secondly, they use a few simple control structures in problem solving. And when we talk about a module, we are saying that this is a portion of the main program or groups of processing instructions within the main program. On the other hand, a subroutine is a group of instructions that are written separately from the main program, written to do a certain function, which is frequently used in the main program. So, the job of a subroutine is to be being used during time delays and when doing arithmetic calculations. What are the advantages of a subroutine? Number one, it makes programming structure easier. Number two, the number of errors that could be experienced during coding are reduced. Number three, when there are errors, those errors can be trapped and rectified easily. Whenever you develop a program in terms of subroutines, you have to call a subroutine so that the tasks or the instructions outlined in it can be executed. So when we refer in programming to calling a subroutine, what we are saying is that we want to transfer control from the main program to the subroutine. And then once we are through with executing the set of instructions in that subroutine, we exit from it by using a certain instruction that will cause a program control to be returned to the main program. And therefore, calling a subroutine is the process of transferring control from the main program to the subroutine, and then exiting from that subroutine using a return instruction or a return statement that will cause a program control to be returned to the main program that had a call statement. We shall be able to look at a calling statement and how we call a subroutine shortly in this presentation under the demonstration of a modularized program or a structured program using Pascal. So, what are the main advantages of third generation languages? Number one, it uses English ones and symbols and is therefore even easier to write. Number two, it is machine independent. This means that a program that has been developed using a certain computer can be used by any other computer. And therefore, it simply means that the third generation programs are portable. What are the benefits of the third generation languages? Number one, it is less time consuming to produce the code, and therefore it is less costly to produce programs. Secondly, programmers do not have to familiarize themselves with the internal architecture of the computer, therefore making programming available to a wide range of individuals. Some examples of these programming languages are Pascal, Fortran, COBOL, BASIC, C, and amongst the others. Pascal is of various types. Some of those types are Talbot and Delphi. Pascal programming language was developed as an academic language in order to help the teaching and learning of structured programming by Nicholas Wirth in the year 1970 at the Technical University in Zurich, Switzerland. Fortran is a short form for formula translator. This language was used for writing scientific and mathematical programs and was used by engineers and scientists for complex mathematical calculations. It enabled writing of programs with mathematical expressions and was developed in the year 1956. COBOL is an acronym for Common Business Oriented Language. Just as the name indicates, COBOL was developed on the side for developing programs that solve business problems, and it came into use in the year 1960 or in the years 1960s. On the other hand, BASIC is an acronym for Beginners All-Purpose Symbolic Instructional Code. It is a simple general-purpose language that was used for developing business and educational programs. C was and is a programming language used for developing system software such as the operating system. It was developed in the mid-1970s. ANDA is a programming language that was suitable for developing military, industrial, and real-time systems. It was named after the first lady programmer by the name Ada Lovelace. The following is therefore an example of a program written in a third-generation language, specifically Pascal. And this program is meant to calculate the speed of an object undergoing through uniform acceleration. And here is the example that I have written or coded for you, my dear student, and the rest of the learners, to help you have a glimpse or a general understanding of how we develop a modularized or structured program using Pascal. When we are writing Pascal, we normally begin with the header, program speed. The name of this program is speed because it is meant to calculate the speed. I will explain each of these statements one at a time after this program. Statement number 2 is a comment in Pascal. This comment indicates that this program calculates speed at time t. In bracket v, the initial speed is u, and acceleration is a, and the time is t. Then we declare variable. And in this case, statement number 3 is var for variable, and the number of variables we have is v, u, a, t, and the type of data that these variables or these memory locations will hold is of type real, simply meaning it is data that contains fractions or decimal points. Then we have our first module or our first subroutine by the name inputs. So it is procedure inputs. Each procedure has a structure like that of the main program. And therefore, we have the statement begin, then write line, enter the object's initial speed. Once the user is prompted to enter the initial speed value, The next statement number 7 is to read that value that will be entered by the user after pressing the enter key, and that value will be read and stored in the memory location set aside and given the name U. Then the user will then be prompted again to enter the acceleration, and the user will type the value for the acceleration and then press enter. After pressing enter key, the value that has been entered by the user will then be stored in the memory location called A. From there, the user is then being prompted to enter the time taken, and the user will type the value, press enter key. That value which he or she will have typed will then be read and transferred or stored in the memory location set aside and given the name T. And that will bring or brings to the end the procedure or the module 1 that we have called inputs. The next module is calculation. And because this is a procedure, it begins with the keyword procedure calculation. This module is meant to perform the processing task, store the value in the memory location, and display the results. That is, display the velocity. And this is our second module. Just as I have said, each module or procedure begins with the keyword begin. Remember, the header for the procedure is procedure followed by the name of the procedure. In this case, is calculation. So from begin, because this procedure is for making calculations or tabulating the data, we have the first statement number 15, reading v colon equals to u plus a bracket or plus bracket a times t. We close the bracket, then we have semicolon. I will explain this sentence deeply, but it is simply an assignment statement where it is informing the compiler to pick the value stored in the memory location called U and 2, the product of what is the memory location called A multiplied by what is the memory location called T, and assign the results or the answer to the memory location that we have set aside and given the name V. Then the module is required to display the velocity or the statement, the velocity for the values entered is, pick the value which is in the memory location called V, display it on the screen formatted with 3 significant digits and 2 decimal places. And then we end the procedure. From there, the next statement is the main program. This is the comment to indicate that this is the main program. And just as it was for the procedures, the only difference between procedure and the program header, procedure header and the program header in Pascal, is that program header begins with the keyword program followed by the name of the program, while procedure begins with the keyword procedure followed by the name of the procedure. And therefore, the main program also has the body, which begins with the heading begin. And then we have the first call statement for the first module, which we have called inputs. So it is calling module 1. The next statement is calculation. This is a call statement to module 2. And then the next statement is to pause the screen to allow the user to be able to see the results of the calculation. And finally, we end our program. Let's now define each of these statements one at a time, beginning with line 1, program speed, semicolon. This is the program header. The word program indicates the beginning of the program whose name is speed. Every Pascal program starts with this reserved word. A reserved word in a programming language is a word which has a predefined meaning in the programming language, and it cannot be redefined by the programmer. Examples of other reserved ones in Pascal include program, var, begin, write line, write, read line, read, procedure, add, amongst the others. Line 2, which we have seen, is a comment that is added in a program in Pascal in order to tell a programmer what each part of a program does. These statements are not executed or recognized by the compiler. To add a comment in Pascal, you enclose the explanation between the braces, the opening and the closing brace. Line 3, which is var, v, u, a, p, colon, real, semicolon, means var is a short form for variable. A variable in a programming language is a location for data that keeps on changing in the memory of a computer. Simply, a variable is a memory location that holds data whose value continues to change with the time. So, line 3 statement tells the computer that variables are about to be declared, or the keyword var tells the computer that variables are about to be declared. When a variable is declared, the computer sets aside some memory space to store a value in the variable. So, declaration section is that section between the program header and the reserved word begin, in which various data items that are used within the program are defined. When we talk about declaring data items, what we mean is that we are telling the computer to reserve memory locations in which the values for the data items are to be stored. The order of declaring data items in this section, especially in Pascal, are in the following order. We begin with the uses on top, followed by labels, then constants, type, variables, and lastly, we have procedures and functions. A data item is declared by specifying the declaration type, that is the data item category, followed by the data item, or what we call identifier, and the data type to be stored. For example, our keyword is var. Then our data items or memory locations that we are setting aside are v, u, a, and t. And the type of data that each of them will hold is of type real. I will explain more about data types in this presentation in the next few screens. In Pascal, each statement is separated from the other by a semicolon. Simply, you terminate each statement or each instruction in Pascal with the use of a semicolon. In this case, therefore, var is the data category, v, u, a, and t are the identifiers or the data item names, while real is the data type. Identifiers in a programming language are the names that are used in a program, which is normally a string of letters and digits that are used to identify the memory locations that are set aside to store values. The four main rules of identifiers are: number one, the identifier must start with a letter of the alphabet. Secondly, it must never start with a number. The third rule is that it should not have special characters or symbols. And number four, it should not have spaces in between. Standard identifiers are the names that have been or that have a predefined meaning in a programming language and are also called reserved ones. For example, real, char, Boolean, integer, amongst the others. During declaration of data items, a data item name, that is identifier, should be followed by its data type, and both must be separated by a colon, just as I have said. For example, v, u, a, t, then full colon, real, semicolon. And data type is normally the nature of value to be taken by a memory location. For example, the nature of values to be taken by memory locations v, u, a, and t is values that have fractional parts or that can allow decimal points. Line 4 is procedure inputs, semicolon. And the comment is it accepts the inputs, and that is starting point for module 1. So this statement is a declaration of a procedure or a module. A procedure is an event or a self-contained blocks of code or commands that can be accessed and used by programmers. This procedure is called in line 20, as we have seen, using the call statement. The code procedure will normally carry out a specific function that it was designed to do. For example, in this program that I've already illustrated, we have seen that we have two procedures. One procedure was carrying out the function of inputting values, while the second procedure was carrying out a computational task. Subroutines and functions are examples of procedures. Line 5 is begin. The begin statement in Pascal, either under a program or a module or a subroutine, is a statement that shows that this is the start of the program or procedure body. Statements in this section are executed by the computer. Line 6, we have seen it was right line in bracket. Then, inverted comma, enter the object's initial speed. We have the closing inverted comma, bracket, and semicolon. What this statement means is that the right line statement displays whatever that is in the brackets on the screen. In this case, the statements in the brackets are written between inverted commas. The string is sent to the screen exactly the way it appears in brackets. So in this case, when the compiler encounters the line 6, right line, then enter the object's initial speed, the statement that will appear on the screen for the user to read and do as required is enter the object's initial speed. Line 7 is read line U. What this statement means, whenever you experience read or read line statements in Pascal, these are used to read a value and store it in a variable. Then we have line 12, which has the end with semicolon. This statement shows the end of the procedure. If it is followed by a full stop, as in line 23, it indicates the end of the program. And that is what I have explained here, that end semicolon indicates the end of the procedure inputs. So it shows the end of the procedure. But if it is followed by a full stop, for example, end with a period, that indicates the end of a program. Line 15 is an assignment statement. This is an expression that calculates the value of v, or velocity. In Pascal, just as I have said, this is called an assignment statement. The values on the right are calculated. For example, u plus bracket a times t, you close the bracket. What this assignment statement means, or what it tells the compiler, is just as I have said, is get the value stored in the memory location called u and add to the product of what is stored in memory location called a and memory location called t, and assign the result to the memory location set assigned by the name v. Therefore, the values on the right are calculated, then stored in the variable v, which is on the left of the assignment symbol. Assignment statements in Pascal are indicated using a colon and equal sign. Line 16 is right line. The velocity of the values entered is v colon 3 colon 2, close the bracket, semicolon. What this statement means is that this is a right line statement that displays the value stored in v on the screen together with the message and closed by the inverted commas. The statements between the inverted commas are meant to make the output readable on the screen. So what the user will see on the screen is the velocity for the values entered is, that value of the velocity will be in the following format: 3 significant digits followed by 2 decimal places, or 3 whole numbers followed by 2 decimal places. That's the fractional part. Let's now look at data types. When we talk about data types, in Pascal, they are of 3 types: simple, string, and structured types. We begin with the simple data types. These are standard data types. They include integers, real, characters, Boolean, const or constants, string data types. Example is var that we have already looked at. And the structured data types, for example, arrays, recons, files, and pointers. We begin with looking at integers. What is an integer data type? These are those that consist of whole numbers that contain no decimal points. For example, 200. Some of the rules of representing integers in Pascal are: number 1, you should not have commas between the numbers. Number 2, an integer must always start with a plus or a minus sign. Number 3, the value should not exceed the specified maximum or minimum for the data type. Number 4, spaces should not be put between digits. The second data type is real. This indicates that the content of that memory location can contain either a decimal point or an exponent or both. A real number cannot start or end with a decimal number, but it must be between 2 digits. Some of the rules to be observed when writing real numbers in Pascal are: number 1, you should never start with a decimal point. Secondly, commas are not allowed. Number 3, a digit must be present on each side of the decimal point. Number 4, either a decimal point or an exponent must be present. An example of a real data type declaration is var average colon real semicolon. This simply means that we are setting memory location aside called average, whose content will contain a decimal value or a decimal point. The third data type is char. These are single character strings, that is, single characters enclosed in apostrophe. For example, var choice type character. This is a declaration statement. What it indicates is that we are setting a memory location aside called choice, whose content will be a character or a string of characters. Number 4 is Boolean. These are truth values that are either true or false. This data type is used to declare data type, which is of only two logical states, either true or false, and the others yes or no. An example is var gender colon Boolean semicolon. This is a declaration statement which tells the compiler to set a memory location aside called gender, whose content will be changing. That is variable, but the content will be a truth value. That is Boolean. The fifth data type is const. It is used to declare data that does not keep on changing during program execution, and this is opposite of var. We have seen that var or variable is declaring data whose content or setting memory locations assigned whose content keep on changing during the time of processing. But when it comes to const, this is setting memory locations aside that will contain values or a value that does not keep on changing during the processing period. It involves assigning a name to a constant and then using that name in place of the constant during programming. An example of such a statement in Pascal is const pi equals to 3.142 semicolon. What this statement simply means is that we are telling the compiler to set a memory location aside called pi that will contain a value which will remain constant, which will not be changing, and that value is 3.142. User-defined or enumerated data types are those data types that are designed for variables that contain only a limited set of values. It is declared as type, keyword or reserved word type, then the name of the data type that we want to define, which is day. We are saying this is days of the week. And which are those days? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And then we terminate that statement with a semicolon. So we have enumerated the days of the week. And we have called that data type day. We have var day. Then this is days of the week. The type declaration involves creating new data types that can be used during variable declaration. So this data type gives the programmer an opportunity to be able to define his or her own variables or his or her own data types. The names assigned can be used during variable declaration. So you can even define a variable, or you can define a data type with even your name, but it's always going to ensure that those names that we used in programming are meaningful and they are somehow self-explanatory to the readers. Let's now look at the string data types. Data type, or this is data type that stores a sequence of characters. They have to be enclosed in an apostrophe. An example is var second name, then string. The third type is structured data type. These are data types composed of more than one component, and they include arrays, records, files, and pointers. So, the four main data structures used in programming are tables and arrays, records, files, and pointers. So those are structured data types. Structured data types include tables and arrays, records, files, and pointers. Let's look at each of them at a time, commencing with the arrays. An array is a data structure that stores a list of data values of the same type, forming a table or matrix with one or more columns of data and given a single name. Tables and arrays are simply lists of items that can be one-dimensional, two-dimensional, or three-dimensional. Arrays are important because they help computers store only the data and the location of the first data element, and then the other items can be located easily. A table or an array allows you to have a single uniform way of naming a number of related values of the same data type. An array declaration is usually accomplished in two steps. These are, number one, we have type declaration. For example, type array name spanning from 1 to 6 of type character. The second statement or step is variable declaration, where we can have, for example, var name followed by a data type, and the data type in this case is the array name. Let's now look at records. This is a data structure which consists of more than one component, but of different data type. And that's the difference between arrays and records. In arrays, or an array is a data structure that consists of one component of data type, while record is a data structure, but which now consists of more than one data type. And data record is a group of related items or related elements that we can treat as a single group. It is normally in Pascal declared as keyword type, followed by the name of the record, students, which is equals to record. So we are declaring a record. And under it, we have the following fields: first name, which will be of type string, then age and birth date, which will be of type integer. And we add that declaration of the record. And then we have a variable that will enable that declaration to be functional, or that definition. I repeat, type students equals to record, first name string, age, birth date of type integer, and end, normally that is definition of a record. But then to declare that record, we use a variable. So in this case, I am using the variable name details, and the data type is of type students, which is the defined record. So every record definition is followed by a variable declaration of that type. And data record is therefore a group of related data items that we can treat as a single group. Let's now look at files. This is a large organized data structure that contains related data items. Or in other words, we can say it consists of several records. Files are mainly used for storing programs and data in secondary storage. How do we declare it in Pascal? Just as it was for records, we also declare files in 2 steps. The first step is to declare the type. So we call it type declaration. Example being type students is equals to file of record. And then under it, we have first name field, which is of type string, age of type integer, birth date of type integer. And then we end that declaration. And then from there, we have what we call the variable declaration of that type. That is, in this case, my variable is student rec, and it is of type students. And remember that students is type of file. In other words, students is the name of the definition that I have for my file. The other data type is pointers. This is a variable that stores addresses of another variable address. Let's now look at the 4th generation languages. These are programming languages that frees the programmer from the tedious work of writing lines of code through the use of controls and application generators. Controls are graphical objects on the screen that a user selects and uses them to create designs on a base form. The application generator is used to generate the necessary code, hence freeing the programmer from the tedious work of writing the code. The main objectives for designing these languages were, number 1, to help speed up the application building process, thereby increasing the programmer productivity. Secondly, it uses English-like statements that are very user-friendly, and therefore, the programs written in 4th generation language are easier to write. Their grammar is natural, near English language. Number 3, this reduces the time taken to develop programs. Number 4, it also reduces the cost of software development. Number 5, they contain inbuilt function wizards that assist the user in solving problems. The 4 generation languages normally fall into the following categories, or in other words, the 4th generation languages fall into the following categories. Number 1, we have what we call the database query languages. Query languages enable non-programmers to use certain easily understood commands in order to search and generate reports from a database. They include structured query language. Number 2 is report generators. Examples are Oracle Report, RPG3, RPG4, that is Report Program Generator 3 and Report Program Generator 4. Number 3 is data manipulation, analysis, and reporting languages. Example, BA Focus. Number 4 are data stream languages. Examples being, or an example being, Iris Explorer. Number 5 are screen pointers and generators. An example is Oracle Forms. Number 6 is graphical user interface generators or creators, or what we call GUI creators. An example being Visual Basic. Number 7 is application generators. This contains a number of modules that are logically related program statements that have been pre-programmed to accomplish various tasks. An example being 05 Pascal, Visual COBOL, C++, amongst others. Number 8 is decision support languages. An example of SQL programming code is use stock list, select all items where price is greater than $30. That's a simple SQL programming code. Let's now focus on fifth generation languages. These are programming languages that are designed to make the computer to solve the problem for the programmer by the computer depicting human-like intelligence, thus helping the programmer not to spend a lot of time coming up with a solution, but only worry of the problem to be solved and the conditions to be met. The main difference between fourth generation languages and fifth generation languages is that fourth generation languages are designed to build specific programs, while fifth generation languages are designed to make the computer solve the problem for you. All codes for the fifth generation languages are automatically generated. A fifth or fifth generation language program is written by specifying certain parameters and constraints. It uses a visual or graphical development interface to create a program that is usually compiled with a third generation language or fourth generation programming language compiler. They are used mainly in artificial intelligence. Examples of such programs include Prologue, Mercury, Lisp, Occam, OPS5, or Official Production System 5. The following is an example of a Prologue program. First statement, computer trainer. Meme. Is computer trainer meme? Yes. Is trainer James? No. That's an example. What does it mean? Line 1 means that the program code meme is a computer teacher. Line 2 asks the question, is Meme a computer teacher? Line 3, the program returns yes. Then in line 4, a question is asked, or the user asks a question, is James a teacher? And the program returns no. Let's now look at object-oriented programming languages, or OOP. These are programming languages that are used to develop programs in terms of objects that interact to make up a whole, with each object having data and functions that are linked together to form a complex program. A program is organized into objects that have relationships with each object, containing both the data and the processing operations necessary to perform a task. They are used in the development of graphical user interface operating systems and application programs. Therefore, a program is looked at as having various objects interacting to make up a whole. Each object has specific data values that are unique to it, called state, and a set of the things it can accomplish, called functions or behavior. The process of having data and functions that operate on the data within an object is called encapsulation. It ensures users do not change the internal state of the object in unexpected ways. On the other hand, an object is a representation of a software entity, such as user-defined window or a user-defined variable. Also, a class is a template that specifies the data and the behavior of an object and is a static description of a set of objects. Classes in object-oriented programming languages are treated in hierarchies, and inheritance lets you pass the data and behavior of an object in one class down the hierarchy. Object-oriented programming enables rapid program development. Every object has properties which can be set, such as color, size, data source, amongst the others, without any programming effort. Every object has also events associated with it, which can be used to trigger certain actions. For example, remove the window from the screen on clicking the close button. Some examples of object-oriented programming languages are Visual Basic, Access Basic, Visual C++, Object-COBOL, Simula, Java, Smalltalk, amongst others. Object-oriented software development focuses more on defining relationships between previously defined procedures or objects. Object-oriented programming is therefore a process by which a program is organized into objects, with each object containing both the data and the processing operations necessary to perform a task. And for that reason, programs developed are called object programs. Object-oriented programming is more flexible and it allows making changes to the programs at ease. This makes it widely popular in large-scale software engineering. It is often simpler to develop and maintain, lending itself to more direct analysis, coding and understanding of complex situations and procedures than other programming methods. Abstraction in object-oriented languages is that ability for a program to ignore some aspects of the information that it is manipulating. Inheritance, on the other hand, is permitting objects to be defined and created that are specialized types of already existing objects while sharing and extending their behavior without re-implementing that behavior. Therefore, object-oriented programming emphasizes on the following concepts. Number one, objects. Number two, abstraction. Number three, encapsulation. And number four, inheritance. Let's now look at web scripting languages, or what we call internet programming languages. These are programming languages used to develop or add functionalities on web pages. Scripting is the process of developing small program fragments written using a different language other than HTML, but inserted into HTML program. Web pages are hypertext documents that are created using hypertext markup language, or what we abbreviate as HTML. So, some examples of scripting languages are HTML, JavaScript, VBScript, amongst others. HTML consists of a special word enclosed between less than and greater than symbols, or what we call tags, that are interpreted by the web browser software in order to display the text when the HTML file is opened on the screen by a web browser software. A tag is interpreted as a command. The two types of tags used are the opening tab that looks as follows and the closing tags that looks as follows. Text that is to be displayed on the screen is enclosed between the opening and the closing tags. The markup tags tell the internet browser that the file contains HTML code information and is distinguished by a file extension of HTML. For example, mlswap.ict.html. The markup tags, on the other hand, define the various components of a worldwide web document, such as heading, tables, paragraphs, lists, amongst others. HTML does not have the declaration part and the control structures, hence it's not considered a true programming language. Due to its simplicity, however, it has many limitations and it cannot be used alone when developing functional websites. One of the advantages of scripting languages over other languages is that they are usually faster to program and the script files are typically much smaller. However, scripting languages are often interpreted, maybe significantly slower to execute, and may consume more memory when running. The types of scripting languages are, number one, application-specific languages. For example, Quaxy, ActionScript, and GameMonkey script, amongst others. Number two is what we call text processing languages. Examples are Unix's AUK, we have Perl, we have PHP. Number three is what we call job control languages and shells. Examples are AppleScript, MS-DOS Bunch, amongst others. Number four is general purpose dynamic languages, which include Perl, PHP, that is hypertext preprocessor, amongst others. Some examples of HTML tags and their meanings are, number one, we have this statement. Here we have the less than sign, HTML greater than sign, then less than sign, / HTML greater than sign. This marks the beginning and the end of a HTML document. All other tags and text fall between these two tags. Number two, we have the less than sign followed by a head, greater than sign. Then we have the other tag, less than sign, / head, then greater than sign. These tags marks the header part of the document. Number three, we have less than title, greater than, then less than, / title, less than. This gives title of the web page. The text between these tags appear in the title bar when the page is browsed. Now, my dear students and the rest of the learners, the first one, less than HTML, greater than, we call that opening tag for HTML, while the second part is the closing tag for HTML document. Then on the second statement, the head one, the first one is the opening tag for the header section, followed by the closing tag for the header section. Number three, we have the opening header for the title, and then we have the closing header for the title or closing tag. I repeat, we have the opening tag for the title, and then we have at the end of the title, we have the closing tag for the title. So number three, it gives title of the web page. The text between these tags appear in the title bar when the page is browsed. Number four, we have the opening tag for the body and closing tag for the body. Whenever you open a tag, at a certain point, you must have the closing tag. So, number four marks the body part of the document. Number five, we have the opening tag center, and then we close that tag for the center. So that this tags or this pair of tags centers text and objects on the web page. Then we have the opening tag from B for brooding and the closing tag for brooding. It bolds the text on the web page. So the text enclosed in between the opening tag for B and the closing tag is brooded. Number 7, we have the opening tag for italicizing and the closing tag for italicizing. So that pair of tags italicizes whatever text that is between them. Number 8, we have the opening tag for header 1 and the closing tag for that header. Whatever is written in between this pair of tags sets size of that text on the web page with H6 displaying the smallest and H1 the largest size. An HTML program can be keyed on a notepad's program's screen. Then after typing the entire program, you save your file with a .html extension, and then you close the notepad. In order to view the contents of that web page that you have developed, you double-click the icon of that file that you have created. Let's now look at the advantages and disadvantages of low and high-level languages. We begin with the low-level languages. The advantages include, number 1, the CPU understands machine language directly without translation, and therefore it lends itself to quick data processing. Secondly, they can be written to take advantage of the peculiarities in the architecture of the central processing unit. Number 3, programs written in a low-level language can be extremely efficient, therefore making optimum use of both computer memory and the processing time. Number 4, the programs written in low-level languages are stable and hardly crash or break down once written. Number 5, the programs coded in this level of language are executed faster because complex instructions are already broken down into smaller, simpler instructions. However, it has certain disadvantages, which include, number 1, writing programs in low level takes a substantial amount of time, as well as inner workings of the processor itself. Secondly, they are typically used for very small programs or for segments of code that are highly critical and that must run as efficiently as possible. Number 3, they are difficult and cumbersome to use and learn. Number 4, they require highly trained experts, both to develop and maintain the programs. Number 5, removing errors or bugs is difficult. Number 6, they are machine dependent and therefore they are not portable. Number 7, the programs are normally very long. Number 8, one must understand the hardware to be used well. What about high-level languages? The advantages of high-level languages include, number 1, they permit faster development of large programs, for they require less time to code. Secondly, they are portable. That is, they are not machine dependent. Number three, they are user-friendly and easy to use, as well as learn. Number four, they are more flexible, hence they enhance the creativity of the programmer and increases productivity in the workplace. They are much more easy to correct errors, or what we call debug. Number five, one does not need to know how the machine is to translate the programs to be executed by it. Number six, they provide better documentation. On the side of disadvantages, the high-level languages, or in high-level programming languages, one must have knowledge of the programming language to be used for each. Secondly, if wrong data is keyed into them, they generate wrong information. Well, number three, a programming language may not notice logical errors. Number four, the complexity of the instructions cause slower program processing. Number five, they have to be interpreted or compiled to machine-readable form before the computer can execute them. Number four, their nature encourages use of many instructions in a word or a statement. Hence, the complexity of these instructions cause slower program processing. Number five, they require large CPU storage capacity for compilation. Lastly, let's look at how we describe various terms in programming. We begin with a source program. This is a set of instructions that a programmer codes using a particular programming language that must be translated into machine-readable form for the computer to understand. The set of instructions to be translated are entered in the program's editor window. It is also called source code. Source code consists of the programming statements that are created by a programmer with the text editor or a visual programming tool and then saved in a file. Source code is usually in a human readable form. Before a written program is compiled or interpreted, it is therefore called a source code. What about object code? This is a sequence of instructions that are in machine-readable form, which are generated after the translation of the source code. Therefore, an object code program is a set of instructions that are coded in a form that the computer can read and understand directly without any further translation. The object code file contains a sequence of instructions that the processor can understand, but is difficult for a human to read or modify. When you purchase or receive operating system or application software, it is usually in the form of compiled object code because software vendors usually don't want you to try to improve their code since this may create additional service costs for them. An object file format is therefore a computer file format that is used for the storage of object code, which is produced by a compiler or assembler. The object codes contains compact code, often called binaries, that are linked with other object codes in order to generate a final executable code. The execution of a program usually occurs in two distinct steps. Number one, the interpreter or the compiler translates the source code to machine code. Secondly, the machine code is then executed. Let's now look at translator. This is a language processor that converts the source program into object code. It is that program which converts statements that have been written in one language, that is in high-level language or assembly language, to statements in another language, which is normally machine readable form, or what we call low level. The three main types of translators that we normally find in programming languages are assembler, compiler, and interpreter. An assembler is a program that translates set of instructions coded as mnemonics, that is assembly language, into machine language code that the computer can understand and execute. This program takes basic computer instructions that correspond to the basic machine operations that the computer can perform, and then convert them into a series of ones and zeros of a given length. The assembler program takes each program's statements in the source program and generates corresponding bit streams or patterns. Assemblers also provide the ability to use symbolic names for memory locations, therefore saving tedious calculations and manually updating addresses when a program is slightly modified. The assembly code is used when it is possible to make the computer perform a task using any language. Let's now define a compiler. This is a special program that processes the entire source code that has been written by a programmer using a high programming language into object code that a computer's processor uses. It gives the programmer the opportunity to code the entire program or the whole program and then convert the whole of it at once. And therefore, it enables the programmer to code the entire program and then come back to correct errors. The compiler translates each high-level instruction into several machine code instructions in a process that we call compilation, and it produces a complete independent program that can be run by the computer as often as required without the original source program being present. The object code file can be made into a fully executable program by carrying out another process known as linking, which joins the object code to all other files that are needed for execution of the program. Using a compiler earns slightly to the time needed to develop a new program because the machine code program must be recompiled after each change or correction. After compilation, the compiler flags all the errors in the program by creating a list of errors. Hence, the programmer must return to the source code and fix the errors. The four main functions of compilers, therefore, are: number one, they translate high-level languages to machine code. Number two, they detect and print the syntax errors in the whole program at the end of compilation. Number three, they organize the storage of variables used in a program. Number four, they link the programs with the operating systems. The main advantages of compilers over interpreters, therefore, are: number one, programs can be executed faster than when using an interpreter, as the object codes are saved and can be run at any time without further translation. Number two, the object codes are harder for a user to change than the source code, and thus are very good for selling commercially produced programs in. The main disadvantage of compilers is that as the entire program is translated to object code, it uses much more of the computer's memory. Let's now look at interpreters. An interpreter is a program that converts the source program into an object code line by line, while allowing the CPU to execute one line of code before translating the next and checks for any errors. The translated line is not stored in the computer's memory, hence every time the program is executed, it has to be translated. Therefore, it means that every time the program is needed for execution, it has to be translated. Interpreters can immediately execute high-level programs. For this reason, interpreters are sometimes used during the development of a program when a programmer wants to add small sections at a time and test them quickly. In addition, interpreters are often used in education because they allow students to program interactively. The main functions of interpreters, therefore, are: number one, they translate high-level languages to executable programs. Number two, they detect and print errors in the program one line at a time. Number three, they organize the storage of variables used in a program. Number four, they link the programs with the operating systems. What about the disadvantages? The advantages of interpreters over compilers are: number one, they translate one instruction at a time, therefore it uses minimum amount of computer's memory. Secondly, they also help in the debugging process because the interpreter can relate error messages to the instruction being executed. Number three, interpreted programs can be easily edited. Number four, interpreted programs run immediately. Number five, versions of interpreted programs are shorter than the machine code equivalent. Number 6, interpreters are portable. That is, they can be run in different machines. Number 7, interpreters are cheaper than compilers. What about the disadvantages of interpreters? The main disadvantage of using an interpreter is that it takes longer to run a program as time is spent interpreting the source code every time the program needs to be run. What about the loader? What is a loader? This is a program that is used to offload programs into main memory that are already stored, and then you can execute your program when it is in the main memory. It also helps you to load your program directly into the EEPROM. That is erasable, programmable, read-only memory. The other term is linker, or the other program that is found in programming languages is a linker. This is a program that allows you to link two or more programs that have been developed separately and make them run smoothly. The other one is Debugger. This is a program that is used to scan the programs you have coded using a high-level program language to check whether it's correct, and then pick up the syntax errors that needs corrections. It enables you to delete and correct errors that may be found in the source program. It also detects syntax errors and allows the programmer to modify as well as change the source code. It does an activity that we call single stepping, which is a method of trying to find out the contents of a register or memory step by step. Single stepping allows the programmer to know how a program has been sequenced in the memory and the contents contained in the register. The other one is monitor. This allows the computer to come on and communicate between the input-output devices that are found in every computer. Then editor. What is editor? Editor enables you to write your program on the screen, so it clears the screen and enables you to write your source code program. Examples of advanced editor programs are word processors. With that, we have come to the end of part 1 of the 4-part series of presentations on elementary programming principles. You can now proceed to listen to part 2 of 4 of this series of presentations by the title Program Development. Congratulations for learning part 1 of 4 in elementary programming principles topic. You can access part 2, part 3, and part 4 of the topic, as well as other computer or ICT videos by clicking or tapping on Emily Swap ICT YouTube channel below this video. You can also visit Emily Swap Life Skills YouTube channel for free life skills, motivational, and inspirational resources. To subscribe to this channel, kindly tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write to us through the email emilyswap@gmail.com. Thank you very much for listening to me, and let's meet in the second part of these presentations in the video posted in the YouTube channel by the name Emily Swap ICT. Thank you very much, and God bless.